Okay, today I'm going to continue reading this book. Okay, I put headphone here. Okay, maybe you guys wonder what is this one. I used to protect my hand while I'm working because that I feel I'm hurt at my wrist. So that is help me. But continue reading. Okay. WebAssembly. WASM. One remaining concern that it has driven a significant amount of JS evaluation is performance, both how quickly JS can be passed, compiled, and how quickly that compiled code can be executed. In 2015, sorry, I think I kind of got like start with slow and then we'll move forward a little bit quicker. I hope so. In 2013, engineer from Mozilla Firefox demonstrated a part of the Urius 3 games engine from C to JS. The abilities of this code to run in browser JS engine at full 60 FPS performance was predicated on a set of optimization that the JS engine could perform. Specifically, because the JS version of the Unreal Engine's code use a style of code that for favors a subset of the JS language name ASM.js. This subset is JS written in way that are somewhat uncommon in normal coding, but which singles contains an important typing information to the engine that allows it to make key optimization. ASM.js was introduced as one way of addressing the pressure on the runtime performance of JS. But it's important to note that ASM.js was never intended to be code that was altered by developers, but rather a representation of programs having been transpiled from another language such as C, where these typing annotations were inserted automatically by the tooling. Several years after AMS.js demonstrated that variety 5 of Turing's created version of program that can be processed more effectively by the JS engine. Another group of engineers also initially from Mozilla released WebAssembly. WebAssembly is similar to ASM.js in that its original intent was to provide a part of non-JS program C or anything else to be converted to a form that could run in the JS engine. Unlike ASM.js, WebAssembly choose to additionally get around some of inherent delays in JS pressing computation before program can execute by representing the program in the form that is entirely unlike JS. WebAssembly is a representation format from akin to assembly, hence its name. That can be produced by a JS engine by skipping the pressing compilation that the JS engine normally does. The pressing compilation of a WAMS targeted program happens ahead of time, AOT, was distributed in a binary package program ready to the JS engine to execute with very minimal processing. And initial motivations for WAMS or WebAssembly was clearly the potential performance improvements which thus continue to be a focus. WebAssembly is additionally motivated by the desire to bring more parity of non-JS languages to the web platform. For example, if a language like Go supported threaded programming, but JS is a language does not. WebAssembly offers the potential for such a Go program to be converted to a form to JS engine can understand without needing a trace feature in the JS language itself. In other words, WebAssembly relieves the pressure to add features to JS that are more likely exclusively intended to be used by transpile programs from another languages. That's interesting. That means JS feature development can be judged by TC39 without being skipped by interest demands in other language ecosystem while still letting those languages have a viable path onto web. Another perspective on WAMS that merging is interestingly not even directly related to the web. WebAssembly is evolving to become a cross-platform virtual machine of sorts, where programming can be compiled once and run into varieties of different system environments. So WebAssembly isn't only the web, and WebAssembly also isn't JS. Ironix Curies even thought WebAssembly run into the JS engine. The JS language is one of the least suitable language to source WebAssembly programs with, because WebAssembly relies heavily on static typing information. Even TypeScript ostensible JS static type is not quick suitable as it stands to transpile to WebAssembly. Thus, language variants like AssemblyScript are attempting to bridge the gap between JS and TS and WebAssembly. This book isn't about WebAssembly, so I won't spend much more time discussing it. Expect to make one final point. Some folks have suggested WebAssembly point to be future where JS exists from or minimized in the web. Interesting. Those folks often have ill feeling about JS and want some other language, any other language to be replaced with since WebAssembly lets other language run into JS engine. Is it fact? It is a engine. On its face, this isn't entirely fanciful variables, but let me just state simply. WebAssembly will not replace JS. WebAssembly significantly argument what the web including engines can be accomplished as a great things and entirely orthogonal to whatever some people will use it as an escape hatch from having to write JS.